Welcome students. In this video, let us look at the topic of location of roots. So if you have a quadratic equation ax square plus bx plus c is equal to 0, we know that this equation has two roots alpha and beta. Now, what is the condition that the coefficients have to satisfy for both these roots to be positive? So the first condition that we are going to look is if both roots are positive. So if both roots alpha and beta are positive, what is the condition that ABC has to satisfy? So let us look at this. So if both roots are positive, first condition is the discriminant has to be greater than or equal to 0, because only if the roots are real, then we can talk about the positiveness or negativeness of the roots. So first the roots have to be real, then only we can talk about both roots being positive or not. And the second condition is that, so if both roots are positive, alpha into beta has to be greater than 0. The product of the roots have to be greater than 0. So will it be sufficient? No. If both roots are positive, obviously alpha into beta will be greater than 0. But alpha beta will be greater than 0 if both roots are positive as well as both roots are negative. Now I want both roots to be positive, so along with this, alpha plus beta also has to be greater than 0. So this condition ensures that both the roots are of same sign. That means either both are positive or both are negative. But I want both to be positive. So alpha plus beta also has to be greater than 0. So this implies this condition d greater than or equal to 0 is a very straightforward condition. Next, alpha into beta is nothing but c by a. So c by a has to be greater than 0, and alpha plus beta is minus b by a. Minus b by a also has to be greater than 0. Or this implies b by a has to be less than 0. In other words, d should be positive, the discriminant has to be positive, and c by a is greater than 0. That means a and c should be of same sign. A and C should be of same sign, and B by A has to be negative. That means B and A has to have opposite signs. So effectively what this means is this first coefficient and last coefficient should be of one sign and B should be of the opposite sign. If that is so, the roots of that equation will be positive, provided D is greater than 0. So let us go to the next condition. So what if both roots are negative? Both roots are negative. Then what are the conditions that needs to be satisfied? So d should be greater than or equal to 0. Alpha into beta has to be positive, because if both roots are negative, if you multiply those two roots, the answer will be a positive number. So alpha into beta has to be greater than 0. And third is this time alpha plus beta has to be less than 0. So if alpha beta has to be greater than 0, then either both roots are positive or both roots are negative. If alpha plus beta is negative, that means both roots are negative. So effectively, discriminant has to be greater than 0, and c by a has to be greater than 0, and minus b by a has to be less than 0, implies b by a is also greater than 0. That means c and a should be of same sign, b and a also should be of same sign. That means effectively, if all the three numbers are of same sign, then the roots of the t equation will be both negative, provided discriminant is positive. Next, the third condition is if one root is positive and other is negative, then what is the condition? Again, D greater than or equal to 0 is a general condition which is always valid. So D has to be positive. Second, alpha into beta. So if one root is positive and the other root is negative, what is the product of those two? Obviously the product of those two is negative. So alpha beta is less than 0. And you don't need a condition about alpha plus beta this time. So as long as alpha beta is negative, we can say that both alpha and beta are of opposite signs. So this time alpha plus beta does not really matter. So effectively D has to be greater than or equal to 0 and alpha beta is C by A has to be less than 0. If the first term and the last term are of different signs, then the roots will be one positive and the other negative, provided discriminant is positive. So these three constitute the first set of formulas. So all these conditions are related to the relation of roots with respect to 0. So here in the first case, both roots are positive. That means the graph is intersecting x-axis on the positive side. Both roots are negative. That means the graph is intersecting x-axis on the negative side. If one root is positive and the other root is negative, that means the graph is intersecting x-axis once on the positive side and next on the negative side. So if the graph has to be like this, these conditions have to be satisfied, and vice versa. These are biconditional statements. That is, if this happens, these have to happen. If these happen, this happens. The conditions work in both ways. So if these three conditions are valid, then the graph will be like this. And if the graph is like this, these three conditions are valid. Similarly, with this case, if these conditions are valid, this condition will be valid. If this condition is valid, those conditions will be valid. So this is one way of deriving the conditions. So these three conditions constitute the first set of conditions. Now let us go to the next set of conditions.